Now, let's go back to our completed experiment in the Experiments tab and select the baseline model. Underneath Interpret this model, there is a Diagnose Model on a New Dataset button, which we can click to access the Diagnose Model's functionalities. Let's select the credit score test dataset for this case. This action will bring us to the Diagnostics tab, where we have just created a new Diagnostics row. The message indicates that this request is currently computing predictions, and after a couple of moments, we are going to see new messages indicating the status of the action. Please note that we can create as many diagnostics as we want by clicking on the plus Diagnose Model button. When the model diagnostics is complete, and we can see the time that it took in the Diagnostics tab on the last column, we can click to open the diagnostics. On the top left side of the screen, we receive some information about the dataset that we used for the model diagnostics, the number of rows, the experiment name, and the target column. Underneath the info section, we can see all the scores that have been computed by the diagnostics model on the test dataset. And on the right side, we also have the Download Predictions button, which will give us a CSV file with the predicted percentage of good and bad credit score for each one of the 20,000 rows in our dataset. Underneath this button, you can see Interact with and download in a PNG format a couple of metric plots specific to the experiment type, plots which also appear on the completed experiment page. We have ROC curve, precision recall curve, cumulative gain, lift chart, Kolmogorov-Smirnov chart, and the confusion matrix. Please do not hesitate to take your time and explore them if you wish. Next up, the Visualize Scoring Pipeline button, which shows you a visual overview of what your completed experiment for the final model looks like. This is a pipeline that begins with all the original features from the dataset, which are used as an input for our two final XGBoost models. Each one of the models is using a four-fold cross-validation technique to shuffle the dataset. And if you are wondering, how does Driverless AI determine the number of cross-validation folds or of the models? Wonder no more, because this is related to the knob settings that we decided upon before launching the experiment. After the two models have been trained, they are combined together using stacked methods to give the final predictions. At the end of the pipeline, we can see that the outputs for our prediction are our two unique labels from the target feature, credit score good or bad. You can also further drill down to get a better understanding of what your feature engineering process is. If you click on the first model, you have access to the pipeline visualization inside, and in the first layer, you can see all the original features. On the second layer, you can observe the transformers that have been applied on each feature being fed on the machine learning model. Additional note here, the fitted features of the final model are the best features found during the feature engineering iterations, and the target transformer indicates the type of transformation applied to the target column. If you click on the model itself, there is a new world opening to us with all the decision criteria used. You will also be able to see this detailed pipeline in the documentation that is automatically generated by Driverless AI in the chapter called Final Model. Let's take a look at it next.